Hi, my name is Brandon Graisley. I teach high school computer science, and I want to use an example to explain the basics of object-oriented programming. The example is libraries. There are lots of different kinds of libraries. They come in different sizes, of course, and for different purposes, but they all basically have one thing in common. They store books, and they store them in an organized way. So one way we might conceptualize a library is by thinking of it as a big object, which has a bunch of smaller objects called sections inside them. You may not think of a section as an object in a library, but it's at least a conceptual object. It's a way to divide it up into its component pieces. And each of those sections has shelves in it, and each of those shelves has some number of books, and the books tend to all be different. So we can think of it in another way here. This is a UML diagram, Unified Modeling Language. A library object has a bunch of sections in it, and a section is in a single library. And each of those sections contains a bunch of shelves, and a shelf is in a single section. And each of those shelves contains a bunch of books, and a book is on a single shelf. So we're going to look at this in more detail in a minute. Let's look at just the shelf part of this. So in a programming language, a class is a definition for all the objects that are of the same type. So it describes a few different things. The first part is it describes its properties or attributes. A shelf might have an array or list of books on it, and maybe it has a topic or a genre name that the shelf is appropriate for. It also has a bunch of behaviors or capabilities, things that we can do with the shelf or the shelf can do. In this case, we can maybe retrieve a book or insert a book or look to see whether a book is on a shelf. Now in Java, here is what the UML diagram for a shelf might look like. We have the name at the top, and then we have the properties or attributes in the middle section. We have books, which is an array of book objects, and topic, which is a string. And the book object we would have to define elsewhere as another class. So these are the field variables for a shelf. Down below we have three behaviors or capabilities: get book, insert book, and contains, which each return values, book, boolean, and boolean. And these are called methods. The methods are sometimes called functions or procedures in other languages as well. So a shelf object can, we show the relationship with the book object like this. There is an asterisk at one end of the arrow to say that there can be any number of books on a shelf. And we also have a 1 at the sort of beginning of the arrow to say that a book is on a single shelf. It's not contained in multiple shelves. You might also have another arrow that points to a string object, because there is one object, the topic string. But we usually don't do that for strings because they're kind of everywhere, and that would clutter up the diagram a lot, so we usually leave that out. We could get a little more complicated if we wanted to. Our library concept might be a bit bigger. Maybe sections don't just have shelves, they also have tables, and tables have chairs and so on. And maybe we have a robot or a computer or a 3D printer or something like that that we want to include in our future concept of our library. So let's get back to this Java class now. What does this look like? We have these field variables at the top, and we have the methods at the bottom. So in code, the shelf class begins on line 12, public class shelf, and then there's an opening brace there, and the closing brace to match it is way down at line 29. Everything inside of this is the definition of the shelf class. And you can see we have two field variables, books and topic, that are written in green on lines 14 and 15. So they're right there. And they're defined, usually we define all of our field variables at the top of a class or at the very bottom of a class after all the methods, which you'll see right here. It's a good idea to keep them all together, otherwise they're a little bit difficult to track down and it's just kind of messy. So the field variables are declared at the top, and then there'll be some other method that sort of fills them up, things like these. So let's look at the getBook method, which takes a string. Let me get these arrows out of the way. String book ID as a parameter, and then it returns a book. So the word public means any other part of the program can access it. The book that you see there on line 17, that indicates that getBook returns a book after the code is done running, and the book ID is a string that the method needs that information in order to run properly, in order to know what book to look for. On line 21, we have insert book, which also takes a book as a parameter, a book object, and it returns a boolean. My concept for this is that if you can insert the book successfully, it will return true, but if the shelf is already full, it will return false. And the last method, contains, takes a book as a parameter as well. If the shelf does contain that particular book, it will return true. otherwise contains returns false. So we have a library with sections and shelves with books on them. We turn that into a UML diagram to describe that structure or hierarchy. We use numbers and stars to explain how many of each type of object there can be. We define each of these classes by using its attributes and its behaviors, and we turn that into a Java class with field variables and methods. And eventually we get down to the code, and we would need to do that for each of the different kinds of objects, each of the classes, like the book class and the section class and so on. So hopefully that is a good start for you understanding how object-oriented programming works. And if you have any questions, of course, you can ask me in the comments down below. And if you're part of my class, well, you already know how to get a hold of me. Thanks.